Hello students, welcome to the OK Academy e-learning program. My name is Otin Joseph and I'm your facilitator for grade 7 mathematics. We are going to have a lesson in grade 7 mathematics on the topic operation on sets, specifically on Venn diagrams. In this lesson, we are going to learn how to represent sets with Venn diagrams. We are going to learn how to represent sets, different kinds of sets with Venn diagrams. Then we will also learn how to apply Venn diagrams to solve two-set problems. We are going to learn how to solve two-set problems by using Venn diagrams. So first, we need to know what Venn diagrams are. We need to know what Venn diagrams are. So what is a Venn diagram? A Venn diagram is any diagram in the form of any shape that represents a set. Any diagram that is in the form of any shape. We have a lot of shapes. We have triangle, rectangle, square, circle, oval, star, a lot of shapes. You can represent your set with any of the shapes that you are interested in. So representing a set with any shape of your choice is called a Venn diagram. A Venn diagram. So for example, let's say we have the set A. Set A has these elements A, B, C, D, E, F. I want to represent my set A with a Venn diagram. These are the options. I can represent set A with a rectangle. So you can see the rectangle here, and all the elements in the set A are in the rectangle. So this is a Venn diagram representing set A. I can also choose to represent set A with a circle. So I draw my circle and I put all the elements of set A inside the circle. This is another form of a Venn diagram representing set A. I can also choose to represent my set A with a triangle. So I have a triangle here, and you can see all the elements inside the set A are also inside the triangle. Remember, when you draw your diagram, all the elements of the set must be inside the figure you are talking about. So I have represented the same set with a rectangle, a circle, a triangle. I can choose to represent it with oval, star, or any other shape of interest. So representing a set with any of these shapes forms a Venn diagram. So the next thing we will be looking at in this lesson is the relationship between sets. The relationship between sets. We are going to learn how to represent relationships such as intersection of sets, union of sets, complement of sets, using Venn diagrams. We are starting with the intersection of sets. Whenever you see this symbol between two sets, let's say I have set A here, and there's this symbol, then set B. This is called intersection of the set A and B. It is also a set. What does it represent? The elements or members which belong to set A and at the same time set B form the intersection of the sets A and B. And we usually write it as this. So I create a set, then I look at set A and set B. The elements that are common to both sets, then I put them in that particular set. And I call that set as the intersection of the sets A and B. So this is a set, but it contains the members of A that can be found in B. At the same time, it is in A and it is in B. Such members are put together in this set called the intersection of A and B. In Venn diagrams, you can represent the intersection of A and B as this. The shaded region, the region I have shaded, it's where you are going to place the elements that belong to A and B at the same time. So I cross them so that commonly they will be having some intersections. and the space between their intersecting point, I place my elements there. So this is the set called intersection of A and B. In the case where all the elements of A can also be found in B, then I have to place A inside B, because A is a subset of the universal set, at the same time a subset of B. So this will be my intersection. I will draw A inside B because all the elements of A can also be found in B. But in situations where only some elements of A can be found in B, then this is how my Venn diagram is going to be. Then this region where I have shaded is going to contain the elements that belong to A and at the same time B. So this is how we represent intersection of sets with Venn diagram, either this or that. So the next relationship we will be looking at is the disjoint of sets, or disjoint sets. The first one we looked at where both set A and B are having some common elements. In this situation, A and B have no members in common. No element or member of set A is also a member of set B. So when we have no member of set A being a member of set B at the same time, then we say the two sets are disjoint. So we say set A and B are disjoint sets. Disjoint set. That is, they have nothing in common. They have no members in common. They are written as either this A intersection B is equal to file. This represents a set with no elements, isn't it? So either you write file or empty curly brackets to show that the intersection of A and B is empty. That is, they have no element in common. And in Venn diagram, this is how they are represented. You see here, they are not joining. They have nothing in common. They share nothing in common. So they are standing separately on their own inside the universal set. Okay, so we have set A being on its own and set B being on its own. They have nothing in common. So you place them separately like this inside your universal set. Whenever you do this, you mean that this diagram here is representing the universal sets containing two subsets that are disjoint. Okay, so let's move on to the next relationship. So the complement of a set. What do we mean by complement of a set? Let's take that set A is a subset of the universal set U. Set A is a subset of the universal set U. A being a subset of universal set U means that A is a set that contains some of the elements of the universal set, but not all of them. Okay? Since A is not containing all the elements of the universal set, the elements that are in the universal set but cannot be found in set A form the complement of set A. So the complement of set A is a set that contains the elements in the universal set that cannot be found in the set A. The complement set contains elements in the universal set which cannot be found in the set A. Okay? So if set A is a subset of the universal set U, then the complement is going to contain all the elements that belong to the universal set U, but do not belong to A. Do not belong to A. The complement is written as A prime. So A prime, this is it. If you want to write the complement of set A, you write it as this. Once you put this thing on top, called a prime, it means that these elements are not in set A. Okay? So supposing I was having set B also as a subset of the universal set, then the complement of set B would be written as this. B prime over here. B prime. This is how we represent the complement of a set by a Venn diagram. I have already told you that the set itself, the subset itself, must be written as a circle inside the rectangle. where the rectangle is representing the universal set. You put all the elements of the set A inside the circle. Any elements that do not belong to set A will be written outside the circle, but inside the rectangle. So you can see the space outside the circle, but inside the rectangle is also a set that represents the complement of set A. Okay? So after writing all the elements of A inside the circle, any element that is in the universal set but not in A must be written inside the rectangle also, but outside the circle. And that will represent the complement set. So this is how we represent the complement of a set by a Venn diagram. It is written outside the set, but within the rectangle. Okay? So that is how we represent the complement of a set by a Venn diagram. We are done with our relationships on sets. Let's take one sample question and see how we can solve it by applying Venn diagram. So at this point, I want us to solve one question, one sample question. This sample question is going to help us to understand how to distinguish between all the relationships of sets and also how to represent them using the Venn diagram. Let's read the sample question together. So A and B are the subsets of a universal set. And this is the universal set. The universal set has these elements from the counting numbers 1, 2, 3, 4 up to 18. So these things here mean that we have some element here. So it spans from 1 to 18. Such that A is a set containing even numbers. Remember, A is a subset of the universal set. So every element inside A must be found in U. And B is a set containing the multiples of 3. Multiples of 3. Remember, B is also a subset of U, so every element here must be also here, found inside U. We have been asked to list the elements of the set A, B, A complement, B complement, A intersection B, A union B, A union B complement, A intersection B complement, and A complement intersection B. Then we have been also asked to illustrate our information on a Venn diagram. So the first thing is we have to list all the elements of these sets. So let's start. The solutions. Let's start with number 1. First thing to do here is to list the elements of your universal set. You can see that the universal set here is having some of the elements unlisted. So you have to expand it by showing all the elements of the universal set. I first write my universal set. Yes. So I have my universal set here, containing all the elements from 1 to 18. The next thing I do is to list the elements of set A. Elements of set A. And we were told that set A contains even numbers. So even numbers in the universal set. Every even number in the universal set is a member of set A. So these are the even numbers 2, 4, 6, 8, 10, 12, 14, 16, and 18. So I list them here. Then I move on to list the elements of set B. How do I get the element of set B? According to the question, set B contains multiples of 3. So all the multiples of 3 that are inside the universal set are elements of set B. So these are the multiples of 3 here. So I put them in set B. So these are the subsets. This is the universal set. These are the subsets. You can see that each element in any of these sets can be found in the bigger set here, the mother set here. So this is the mother set. These are the children called subsets. Let's move on, listen the elements of the other set. A complement. A complement. What did I say about A complement? I said A complement is a set that contains elements in the mother set, in the universal set, but are not found in A. So any element that cannot be found in A here, but can be found in the universal set, must be placed in A complement. So let's look at A complement, the element. 1 cannot be found in A, so we write 1 here. We have 2 here. What about 3? 3 cannot be found in A, so it will be in A complement. 4 can be found in A, but we cannot find 5 in A. So 5 will be in A complement. 7, 9, 11, 13, 15, and 17. All these elements are in the universal set, but they cannot be found in A. So they form A complement. Now let's move on with the other sets, B complement. As we did for A complement, B complement is going to be the set of elements that can be found in the mother set but cannot be found in B. Can be found in the mother set but cannot be found in B. So which elements can be found in the mother set but not in B? We have 1 here. We have 2, 4, 5, 7, 8, 10, 11, 16, and 17. All these elements are in the mother set, but they cannot be found in B, so we place them in B complement. The next one is A intersection B. A intersection B. A intersection B is going to be a set that will contain elements which belong to both A and B. So let's find A intersection B. Looking at the set A and B, as you have listed the elements, which elements do you think are common to both A and B? Both A and B. We saw that A contains even numbers that are in the mother set, and B contains multiples of 3. So we saw 6 in A at the same time in B. It's a multiple of 3 and it's an even number. We saw 12 is an even number and a multiple of 3, so it belongs to both A and B. Then we saw 18, which is also an even number and at the same time a multiple of 3. So it can be found in both A and B. So we write these elements here: 6, 12, 18. Have I left anything out? Anything common to A and B? Have I left anything out? No. You can see. No. So we have 3 elements in A intersection B. These elements belong to both A and B. Now let's move on to the next set. The next one is A union B. A union B. A union B is the set that contains the elements in both A and B put together. So I take all the elements in A and all the elements in B put together will give us the A union B. So let's write the elements in A union B. These elements belong to A, 2. 3 belongs to A, at the same time B. So it will come in A union B. 4 belongs to A, so it will come here. 5 doesn't belong to any of them. 6 belongs to A, at the same time B. What about 7? It doesn't belong to any of them. 8 belongs to A, and 9 belongs to B. 10 belongs to A. 12 belongs to B, at the same time A. We have 14 in A, 15 in B. We have 16 in A and 18 in A and B. So this set is called A union B. You can see that you can find all the elements of A and at the same time all the elements of B in this set. So this forms the union of set A and B. All right, let's move on to the next. The next set we have to list is A union B complement. How do we get A union B complement? We have A union B. We have A union B. We have already listed the element of A union B. So the A union B complement will be a set which will contain elements that are not in A union B. So any element that cannot be found in A union B will be a member of A union B complement. So let's try listing the element of A union B complement. One was not found in A union B, so it will be in A union B complement. 5 was not found in A union B, so it will be in A union B complement. 7 will be in A union B complement. 11 will come in there. 13 will come in there, and then 17 will come in there. So checking the A union B, you can see that these elements are not inside. These elements are not members of that set. Therefore, they will fall under A union B complement. Okay? The next set is A intersection B complement. How do we get A intersection B complement? We have A there. You have B complement there. This means that we look at the set A and the set B complement. The element they have in common will be put in A intersection B complement. The elements that are found in A and at the same time in B complement will be put in the set A intersection B complement. So, which elements are going to be in A intersection B complement? We saw that in B complement, we had 1, 2, 4, 5. We had 7, we had 8, we had 10, 11, we have 13, 14, 16, and 17. Right? And in A, we saw they are all even numbers. So it means that in A intersection B complement, B will be in there. That is 2. 2 will be in there. 16 will also be in there. 10 will also be in there. The even numbers that are not in B are the complements. So they will be in there. This one. We also have 14 here. to be in A intersection B complement. Then we also have 8 over there. So you can see that 2 is in A and at the same time in B complement. We have 4 in A and at the same time in B complement. 6 in A and at the same time in B complement. 8 in A and at the same time in B complement. 10 in A and in B complement. 14 in A and in B complement, and 16. Therefore, these elements will come in the A intersection B complement. So we have 2, we have 4, 6 is in B, so it is not part of the A intersection B complement. So we have 8, we have 10, 14, and 16. So these are elements that are going to be found in A intersection B complement. Our last set to be listed is the A complement intersection B. A complement intersection B. A complement intersection B is a set that contains elements that can be found in A complement and in B. A complement and in B. We saw that A contains every even number here. So all the odd numbers are in A complement. And we saw that B contains multiples of 3. So any number which is not a multiple of 3 will be in B complement. But we are talking of B. So B is elements of B which are multiples of 3. And A complement is odd numbers. So let's look at the odd numbers that are also multiples of 3. Then they will fall under A intersection B complement. So we have 5 over here. 5 here is an odd number, but it's not found in B. So we cannot take 5. It's an odd number, but it's not found in B. 3 is an odd number, right? So it will be in A complement. And it is a multiple of 3, so it will be also found in B. Therefore, 3 will be a member of A complement intersection B. Then we have 9. 9 is an odd number, so it will be in A complement. And it is a multiple of 3, so it is common to A complement and B. Therefore, we have 9 here, being a member of A complement intersection B. Then we have 15 here. 15 here is a member of A complement, and at the same time in B, a multiple of 3. Therefore, it falls under A complement intersection B. I think that is all the elements we are going to have for A complement intersection B. You can also find them by checking the A complement sets and the B and selecting your common members from the two sets. Either way, you get the right answer. You get the same thing. So we are done with question 1. I believe by now you'll be able to distinguish between intersections, complements, unions, and all the rest. Now let's go to the last question, which says that we have to illustrate the information above here on a Venn diagram. We have to illustrate the information above here on a Venn diagram. So I draw my Venn diagram, my rectangle for the universal set. It should be big enough, but not too big. So this is going to be the universal set. The universal set has two sets, A and B. They are not disjoint. They have some elements in common. So I have two circles that are intersecting. Two circles that are intersecting. This part here is going to contain the elements that belong to A intersection B. The element that belong to A intersection B. This part is going to contain elements that belong to A only. This part is going to contain elements that belong to B only. And any space outside the circles but within the rectangle is going to contain the complement set. A intersection B complement. So, which elements were found in A and B intersection? The elements that were found in A and B intersection will be written here. We saw that 6 was an even number and a multiple of 3, so it was part of the intersection. We also saw that 12 was an even number and a multiple of 3, so it was part of the intersection set. We also saw that 18 was an even number and a multiple of 3, so it was also part of the intersection set, like this. So this region here, you can see, is containing elements that are in A and at the same time in B. Then I come to here, the elements that are in A but are not in B will be here. What are they? I have 2, 4, 8, 10, 14, and 16. So these are the elements that are in A, but they are not in B. So they will be here, in this region. Then I come here. This region will contain elements in B, but not in A. Elements that are in B, but not in A will be here. We call this region B only. B only. So let's write the elements over there. We have 3, we have 9, we have 15. So we have 3 elements, 3, 9, 15, that are in B but are not in A. Okay? Now, which elements are left out? Which elements are neither found here, here, nor there? Any element that cannot be found here and cannot be found here nor there must be outside the circle, but not inside any of the circles, and must not be outside the rectangle too, within the rectangle. They form the A intersection B complement. What are they? We had 2, we had 1 rather. So we had 1. We also had 5, 7, 11, 13, 15, 17. Any space outside the circles, you can write your elements there, anywhere, provided it is outside the circle but within the rectangle. So this is the solution or the answer for question 2. We have illustrated all our problems in the Venn diagram. This is where we end our lesson for today. We will continue the lesson in our next video. Thank you for staying with me. You know we are not in normal times, so I will urge you to observe all the social distancing protocols, put masks on whenever you are leaving your home, and enjoy better time with our video lesson at home. See you next time. Bye-bye.